Good morning, guys. Today we are going to take a look at something called complex fractions. So when we talk about complex fractions, the big idea is that we have a fraction in the numerator and a fraction in the denominator, or some combination of a whole number and a fraction. The big idea is there's a fraction within part of a fraction. So if we take a look at our intro problem here, we've got some fractions in our numerator of our larger fraction and some fractions in the denominator of our larger fraction. If I want to simplify this, then that means I need to simplify the top, simplify the bottom, and then simplify that large fraction as a whole. So on top here, where I've got 1/2 plus 3/5, that means that I need to get a common denominator to be able to add these. So my common denominator here, my least common denominator really is what we're looking for, would be 2 times 5. So this first fraction has that 2, but it needs the 5. So I'm going to multiply by 5 on top and bottom here. My second fraction, I would need to multiply the top and bottom by 2. So I would get 5 over 10 plus 6 over 10. So that's the top of our larger fraction. And when I go ahead and add these together, I would get 11 over 10. So I've simplified the top to be one fraction. On bottom, same idea. Our least common denominator on the bottom would be 8, since 4 goes into 8. So that means I would have to multiply the top and bottom here by 2. So I would get 6 over 8 minus 1 over 8. Now that my denominators are common, again, we're just working with the numerators here. 6 minus 1 would be 5 over 8. So I've simplified the top of my larger fraction, and I've simplified the bottom of my larger fraction. What I need to do now is simplify the big fraction as a whole. So what we're going to do here is actually treat this not sort of as we would normally think of a fraction, but remember that a fraction is actually representing division. So another way that I could think of this is that I have 11 over 10 divided by 5 over 8. And we know how to divide fractions. We keep that first guy the same, and then we multiply by the reciprocal of the second thing. Now, this is something that we can handle. So we would have 88 over 50. Since my top and bottom are even, I can reduce by dividing both of these by 2. That will give me 44 on top and 25 on the bottom. So our simplified final answer would be 44 over 25. This whole big messy thing reduces to 44 over 25. If we can do that with fractions that are just numbers, we can also do it with fractions that are polynomials. That's what we're going to look at for today, how to simplify complex fractions. You have two methods here listed in your notes on page 12. We're actually just going to stick with method 1. Okay? If you have questions, you can ask your teacher about method 2 as an alternate strategy, but we're just going to focus on method 1. Okay, we're going to focus on method 1 because it uses the strategies we've already worked with, adding and subtracting fractions, multiplying and dividing fractions. We're just using those same processes to be able to simplify these larger problems. So as I take a look at my first example here, what we want to do is simplify the top and simplify the bottom the same way that we did for this example problem. So add these fractions, subtract these fractions, get a single condensed term on top and a single condensed term on bottom. Okay, no more addition. Okay, we basically want to go ahead and do that operation so we don't have to worry about it anymore. So for my top portion of that large fraction here, my least common denominator for the top, if this is 4 over 1, would just be 5. My first fraction already has that common denominator, so I don't have anything to do there. But for my second fraction, I need to multiply the top and bottom by 5. So on top, what I have now is x over 5 plus, that would be 20 over 5. And now since these fractions have a common denominator, I can go ahead and add the tops. So that would be x plus 20 over 5. So I've reduced this to just a single fraction. No more addition there. I've done the addition. It's just a single fraction. And now we're going to do the same thing on the bottom. Again, I could think of this as 8 over 1, and I need my least common denominator for the bottom. That would be x. So I need to multiply the first term by x on top and bottom to get that common denominator. And then my second term already has that common denominator, so we're good there. So this would be 8 times x, that's 8x over x plus 1 over x. Now, one thing that I notice is that a lot of people are tempted to reduce after they get common denominators. So you see x over x and you think, hey, I can reduce that. Or up here you see 20 over 5 and say, hey, I can reduce that. Don't reduce right here. You just went through the work of getting those common denominators. If you reduce, you've undone all that work and then you have to repeat it. Okay, and then you get stuck in this loop of reducing and getting common denominators and then reducing. So remember, the goal here is that the bottoms are the same so I can add. So once you get those common denominators, the next thing you want to do is add. So 8x plus 1, those aren't like terms. So the best I can write there is 8x plus 1. That's as combined as that can be. And then remember, my denominator stays the same. So now I've got one fraction on top of one fraction. So we're going to treat this as division. So I have x plus 20 over 5 divided by 8x plus 1 over x. To divide two fractions, remember, we keep that first fraction the same, but then we multiply by the reciprocal of whatever comes after the division sign. Okay, so I need to flip that second term. So it would be x over 8x plus 1. Now, at this point, if you had factoring that you could do, if you had a GCF to pull out, something like that, that would be okay, because remember, when we multiply fractions, we want to reduce before I go ahead and multiply the tops and bottoms. Here, I don't have any factoring I could do, not even a GCF I could pull out. So I'm going to go ahead and just multiply the tops. So that would be x times x plus 20 over 5 times 8x plus 1. Okay. When we multiplied fractions, we left these things in factored form. So that's okay. You could also distribute here, and that would be fine as well. If you distributed, you would get x squared plus 20x over 40x plus 5. Okay, so that's simplifying a complex fraction. We're just using the addition, subtraction, division, multiplication work that we've already done to help simplify a larger problem. Okay, let's go ahead and turn the page and look at a couple more examples. So on page 13, our first example here, we've got just a single fraction on the top, but on the bottom, we've got some addition. So the top of our fraction is going to stay as is for right now, and we're just going to focus on the bottom. Okay. So we need our least common denominator for the bottom. I can't factor x plus 2 anymore. There's no GCF for me to pull out. It's not an x squared thing that I need to try to factor down. So this is my factored form there. And then on the bottom of my second term here, I just have x. Again, there's no more factoring I can do with that. X is as simple as it's going to get. That's as broken down as it's going to get. So that's my factored form. So my least common denominator would be x plus 2 and x. This first term has the x plus 2, but not the x. So I've got to multiply by x on top and bottom. My second term has the x. It needs the x plus 2. So I'm multiplying by x plus 2 on top and on bottom. So this becomes, the top I'm just going to copy. I haven't done anything there. That stays exactly the same. This becomes x over x times x plus 2. And again, I'm just leaving that in factored form like we did when we were adding and subtracting fractions. Plus, distribute on the top, That would be 2x plus 4. And then again, that denominator I'm leaving in factored form. And now I can go ahead and do the addition for the tops here. Since I have common denominators, I can add. So as I'm recopying this top part 2 over x plus 1, again, I'm just recopying. And then on the bottom here, x plus 2x would be 3x plus 4 over that same common denominator, x times x plus 2. Now that I've simplified the top to one fraction, which to be fair, it already was one fraction, but the bottom I've simplified to be one fraction. I went ahead and did the addition. Now I treat this as division, and I'm going to go ahead and rewrite it as 2 over x plus 1 times the reciprocal of the bottom. So x times x plus 2 goes on top, and 3x plus 4 goes on the bottom. If it helps you to write this out as that division step, so if you need to write out 2 over x plus 1 divided by 3x plus 4 over x times x plus 2, and then flip to this, that's fine. Okay, so if you need to write this step of work so that the flip makes sense to you, write that step of work, that's fine. We're going to end up here. And so now what I want to look to do, since I've got factored form here, I want to check to see if I can factor anything else to be able to reduce. This won't factor. There's no factoring to do there. 2 is prime, so I don't have any factoring to do there either. So all I have left to do is multiply across the top and multiply across the bottom. So this on top here would give me 2x times x plus 2 over x plus 1 times 3x plus 4. That would be our factored form of our answer. I'm going to show you what this looks like distributed as well. So this would be 2x squared plus 4x over, that would be 3x squared plus 4x plus 3x plus 4. So 3x squared plus 7x plus 4 on the bottom if you were to distribute. Okay. There would be my final answer. We're going to take a look at one more example together. Again, same idea, very similar to our last example. I have just one fraction on the top, so I don't have anything to worry about on top here, but on the bottom, I've got some fractions that I'm subtracting. So I need to go ahead and do that subtraction as my first step. My least common denominator on bottom here, I've got a factor of x and a factor of 2. So my least common denominator would be 2x. That means that I need to multiply the top and bottom by 2 in this first fraction and multiply the top and bottom by x in this second fraction. So I get 15 over x plus 2, just recopied, and then 12 over 2x minus x over 2x, or 1x if you want. Now that I have common denominators here, I can go ahead and do that subtraction. Remember, subtraction is the one we need to be careful with because that changes our sign. So I would have 12 minus x on top here, 12 minus x over 2x. And now that I've got one fraction over one fraction, that's where I can treat this like division. So I have my top, 15 over x plus 2, and I'm going to multiply by the reciprocal of the bottom. So that's 2x over 12 minus x. Again, always a good idea to check to see if I can do any factoring that would let me reduce here. We could factor 15 into 3 times 5, but I don't have a factor of 3 or 5 on the bottom to reduce, so I'm going to go ahead and leave it as is. Multiplying across the top, 15 times 2x, that would give me 30x. And then on the bottom, x plus 2 times 12 minus x. So this would be my factor form for my answer here. If you distributed out the bottom, you would end up with 30x over negative x squared plus 10x plus 24. Okay, so that would be your distributed version of your final answer. Okay, and that's simplifying complex fractions from our notes on pages 12 and 13.